Hello ladies, it's Mr. O'Sullivan. Today we're going to be looking at linear function applications. So these are word problems that we're going to be exploring. These are similar to the level of difficulty you'll be expected to do on Delta Math later on for your classwork. So let's get into business. Today's learning target is I can apply my knowledge of linear functions by examining a real-world situation. And one of the things we want you to know is that functions are to be in slope-intercept form for this unit. So remember, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So those are what we're going to be looking at today. So there are three types of problems that you're going to be dealing with. One's where you're given a slope and an intercept. In these cases, you're only going to be given two numbers. Look for your slope words, per, for, each, for every. Look for your intercept words, begin, start, flat fee, initial. Sometimes you'll just be given a slope and a point. In that case, you're going to be given three numbers. Look for the slope words again, per, for, each, for every. And then the other two numbers have a relationship that you're going to have to figure out. And then last but not least, occasionally you'll be given 2 points, which in this case, you're going to have four numbers. And two pairs of two numbers have the exact same relationship. Our first example, a car is traveling along a straight road. After 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. Determine a function for the distance d the car is from Chicago after h hours. The relationship between d and h is linear. First, let's read it one more time. After 1 hour, the car is 72 miles from Chicago. That seems important, so I'm going to underline it. After 3 hours, the car is 188 miles from Chicago. Determine a function for the distance d the car is from Chicago after h hours if the relationship between d and h is linear. The first thing I'm asking you is, what is the independent variable? Whenever you have questions like this, you are in earth science, so you should know independent and dependent variables. Independent variables are always going to be time. So in this case, this is the time we are traveling, because that depends on nothing. So the time traveling, the dependent variable, in this case, well, we have two variables. We have time and we have distance, or the miles driven. So in this case, our dependent variable is distance. Now we want to write the function. Remember, all of our functions are going to be in the form y equals mx plus b. So I'm going to write y equals mx plus b. Where m is our slope and b is our y-intercept. So I need to know my slope and my y-intercept. So let's find our slope. So if I look, I have a relationship. I have after 1 hour, the car is 72 miles away. Remember, time is our x and distance is our y value. So I can say this is an ordered pair, 1, 72. And I can say after 3 hours, I'm 188 miles away. So this is the point 3, 188. What we're going to do is we have 2 points, so we're going to find the slope between those 2 points. So 172 and 3, 188. So we're going to plug those into our slope formula. Our slope formula is y2 minus y1 over x2 minus x1. And if I look, my second y value is 188, my first y value is 72. So I have 188 minus 72 over 3 minus 1. When I type that into my calculator, I get 58. So I get my slope to be 58. Now I need to find my y-intercept, because I have my slope, but I need my y-intercept as well. So now what we're going to do is we're going to find our y-intercept. So when we find our y-intercept, I'm going to organize this over here. So now part 2, find b, or your y-intercept. You're going to pick your favorite point and substitute it into your equation. So right now my equation looks like this. I can plug in a 58 for m, or substitute my 58 for m, so I have y equals 58x plus b. And what I want to do is I want to find out what b is. So I'm going to have to make this an algebraic equation. So I'm going to choose my favorite point. I like to work with smaller numbers, so I'm going to choose my first point right here and know that this is an x value and this is a y value. So I'm going to do 72 equals 58 times 1 plus b. 58 times 1 is just going to give me a 58. And now that becomes a one-step equation. The way to get rid of my 58 is to subtract 58 on both sides of my equation. And I get b is equal to 72 minus 58 is 14. So now that I have my y-intercept, I can put it all together. So again, my equation was y equals 58x plus b. Now I can put in my b of 14. So y equals 58x plus 14. But now, if you look at the question, we want to write this as a function between d and h. H is hours. Hours is time. Time is x. Distance is y value, basically. So where I see my y, I'm going to put a d. So I can say d is equal to 58. And I said my x value is going to be h plus 14. And that's your final answer. Now let's go on to part D. Part D says graph your function. Now part D says graph your function. So what we're going to do right now is we're going to graph our function. This is going to be your x-axis. So this will be our time. Hours. And then this is going to be our distance. You can also put time as your x-axis. If you put hours, that's fine also. There's no right or wrong answer, especially as long as it's just the correct unit. So now we're going to put our distance here. And now what we're going to do is we're going to scale our axes. What I'm going to do is I'm actually going to cheat a little and make my hours go over by 1. Every 2 boxes will be 1. So I'm just going to do that. Every 2 boxes is 1, which is completely fine. You can do this. And I'm going to make every 2 boxes 20. Every box 20. So every 2 boxes will be 40. So this will be 40. 80. 120. 160. 200. 240. And then last but not least, 280. So it's all right now to get a bunch of points plotted. It really is. It's completely fine. So at x equals 1, I'm just going to type these into my calculator. So like 58 times 1 plus 14. I get 72. And you can use the table feature on Desmos. So I'm going to go up to 72. So at 1, I get 72. So that's like around here. At x equals 0, I get 14. Which makes sense because that's my y-intercept. So that'll be like around here. At 2, I plug in 2. and I get 130. So at 2, I get 130. So this is 140, so it's like around here. And I'm just gonna draw my line going through those 3 points. And that's your graph. Let's go on to the next example. Number 2, Preston measures the amount of snow on his porch and discovers 5 inches are on it. For the rest of the afternoon, the snow fell at the rate of 2.5 inches per hour. Write a function to represent the amount of snow on Preston's porch after each hour. So I'm going to read through this one more time. Preston measures the amount of snow on his porch and discovers 5 inches are on it. That seems important, so I'm going to underline it in blue. For the rest of the afternoon, the snow fell at a rate, remember that's a key word, that's a slope word, of 2.5 inches per hour. Write a function that represents the amount of snow on Preston's porch after each hours. Well, we're talking about the amount of snow. So again, the independent variable is always time. So time, and that's going to be in hours. The dependent variable, so we're talking about the amount of snow, so this will be the amount of snow. Well, we actually find this is actually going to be an easier one to write. Remember, y equals mx plus b. M is our slope. B is our y-intercept. We said that the snow is falling at a rate of 2.5 inches per hour. So I can say my equation is y equals 2.5x plus, and he initially saw 5 inches on it. So I'm going to put a 5 here. So my equation is y equals 2.5x plus 5. But the issue is we want to include an h. And remember, we said h is time, which is our x value. So my equation for this is just y equals 2.5h plus 5. That's my function. D, what was the depth when the snowfall began? So whenever something we mean beginning or start, that means our initial value, which is when x equals 0. So what we're going to do is we're going to plug in 0 for h. When I type this into my calculator, or if I just know that rule, anything times 0 is 0. 0 plus 5 is 5. So y equals 5. So what that means is that the initial amount of snow, or the amount of snow that there was 5 inches. What would the depth be after 12 hours? Well, now what we're going to do is we're going to basically just plug in 12 for h. So remember, our equation was 2.5h plus 5. So what we're going to do is we're going to put in a 12 for h. And you just type that right into your calculator. Let's see what we get. And we get 35. So after 12 hours, if I don't shovel or anything, there is going to be 35 inches of snow. And last but not least, we are going to graph the equation. Remember, the first thing we need to do is label our axes. Our x-axis is going to be hours. You can also put time. Our y-axis is going to be the amount of snow. The amount of snow. So here's what I would actually do. Might be a little strange, but here's what I would do. I would change this 2.5 into a nice fraction. I can write 2.5 as 5 over 2, so I can write this as 5 over 2h plus 5, which means I have a rise of 5 and a run of 2. A rise of 5 and a run of 2. What I'm going to do is make my hours go out by every 2 is going to be 1. And then I'm going to make every box 5. So this will be 10, 20, 30. Wait, that's way too big. 1 second. I'm going to make every 2 boxes 5. Basically, every box is 2.5. Every box is 2.5. So you can do the 5 over 2h plus 5, or you can just do the up 2.5 over 1. So I know at x equals 0, my point is going to be 5, because that's our y-intercept. Now what I'm going to do is I'm going to go up 2.5. So this is up 2.5, up 2.5 over 1. That's a new point. I'm going to go up another 2.5, and then over 1. I'm going to go up another 2.5 and over 1. Now, you might have noticed I'm actually jumping 2, but this is really a jump of 1 based off what I scaled my interval to be. Now I go up another 2.5 and over 1, up another 2.5 and over 1, and keep on going. And now I can draw my line going through these points. And now that my line is drawn, I have my equation. Let's go on to our next example. Okay, so Marty's spending money at an average rate of $3 per day. After 14 days, he has $68 left. The amount left depends on the number of days that have passed. Write a function that relates the money he has left m to the number of days d. So when I look at this question, I see that I have an average rate of $3 per day. That's my slope. And he's spending $3 per day. So he's losing money from his bank account. So that's really a negative 3. After 14 days, he has $68 left. I can represent this as an ordered pair as 14, 68, where 14 is my x value, 68 is my y value. We're going to want to write a function soon, so let's get moving. What is the independent variable? Remember, independent variable is always time. So in this case, it's days. And independent variable is your x value. Not your x value, your x-axis. Your dependent variable is your money. That's the only other variable in this situation. So it's the amount of money. And dependent is going to be your y-axis. That's where we're going to be plotting the amount of money. Part C, we want to write the function. Well, we know equations or functions are written in the form y equals mx plus b for this unit, where m is our slope, and b is our y-intercept. So if I look in the question, we said our slope was negative 3 because remember, we're taking money out or spending money, so I'm losing money. So that's actually a negative thing. You don't want to lose money. So my equation is going to look like y equals negative 3x plus b. And I need to find my y-intercept, so I'm going to have to use some algebra to find my y-intercept. So I know that I have a point on this line. So I have 14, 68. Is my x value, 68 is my y value. So everywhere I see an x, I'm going to substitute 14. Everywhere I see a y, I'm going to substitute 68. So I have 68 equals, because that's my y value, 68 equals negative 3 times 14 plus b. When I do the calculation of negative 3 times 14, I get negative 42, so I get 68 equals negative 42 plus b. And the only way to solve for b in this situation is to add 42 to both sides of my equation. So when I add 42 to both sides, I get b is equal to, well, 68 plus 42 is, let's look, 110. So now I have my y-intercept, so I can put it into my equation. So my equation is really y equals negative 3x plus 110. I forgot to put a 1. That doesn't look nice. Negative 3x plus 110. But if you look, I don't want it in y's and x's. I want it with m and d. So remember, d is where you put your x. M is where you put your y. You can do this. M equals negative 3d plus 110. That's your equation. Uh-oh, uh-oh, uh-oh. Now part D, graph that equation. Remember, your x-axis is your time or your days. Your y-axis is the amount of money. So if you look, I have my rate of change is negative 3. I start at 110. So what I'm going to do is actually make my top piece 110. So I'm going to start my graph all the way up here. And I'm going to make every box 3. So I'm basically going to make every 2 boxes 6. So I'm going to make this 104, 98, 92, take away 6, now we're at 86, take away another 6, now we're at 80, take away another 6, now we're at 74, take away another 6, and we're at 68. And remember, this is going to be a break because we're not really starting at 0. We're just zooming in on a portion of our graph. And I'm going to do the same thing I've been doing before. I'm going to make every 2 boxes 1. So I'm starting at 110 because that's my y-intercept. I'm going to plot that point here at 0, 110, and I'm going to go down 3 over 1. So basically I'm going to go down 1 box over 1 is 2. Down 3 over 1. I'm going to follow that same procedure. And now what I'm going to do is I'm going to draw a line going through those points. Let's see what we come up with. And look, we have our line. So we graphed our equation. Now we want to figure out when Marty's going to be broke. So when Marty's going to be broke, that's when he's going to have no money left. When I have no money left, I have $0 in my bank account. So if I look at my equation, we said our equation was m equals negative 3d plus 110. So what I'm going to do is I'm going to put in a 0 for m. Now, to solve for d, I'm going to subtract 110 from both sides. So I get negative 3d equals negative 110. And then I'm going to divide both sides by negative 3. And I get d is equal to, let's see, 110 divided by 3. I get 36.666666 repeating. So it'll take Marty 36.666 days or 37 days to run out of money. Now, how much money did Marty start with? Well, there's 2 ways to approach. You can plug in 0 to your equation. We know our equation is m equals negative 3d plus 110. You just plug in 0. Anything times 0 is 0, so I just get 110. So that's how much Marty started with. There's another way you could have done it. You could have just looked at your equation and saw that your y-intercept was 110. Which tells you that this is my start point. No need to plug in. You can just look at your equation and see that it's 110. And that's it for today. Again, your delta math is not going to focus on graphing. It's going to mainly just focus on how to write the linear equation based off the situation. If you have any questions, please email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.